Hello friends, MoNaCo here. Last video in the unit, moles and stoichiometry. We're going to talk about molecular formulas today and how we figure them out given the formula mass of the empirical compound. This is rare, but sometimes we have to do it. And this kind of the high water mark of moles and stoichiometry, being to be able to do 4 and 5 step problems, is very challenging, but practice makes permanent. So how can we determine an empirical formula? How can we determine a molecular formula if we're given the empirical formula? How do we figure out what the formula for a real molecule is? And this is how we do it. So far, we can find the empirical formula from percent mass. That was in the last video, video 7. And we can find empirical formula from a molecular formula by dropping all of the subscripts down to the lowest common factor. That was in the last video. But how do we find a molecular formula from an empirical formula? So if you're given like CH3, which is an empirical formula, how would you figure out the molecular formula for the compound that it represents? Well, it's a multiple step process. So for example, compound's 80% carbon, 20% hydrogen by mass. If its molecular mass is 75 grams, what is its empirical formula? What is a molecular formula? So it's a two-part type of a problem. First, we figure out that empirical formula by doing the percent to grams, then grams to moles, and then moles to find the basic ratio. So here we go with that stuff. And we're going to need to calculate it in a periodic table in order to do it. So for 80% carbon, we're going to convert that. So we're going to say 80 grams carbon, simple conversion. 20% hydrogen, we're going to say 20 grams hydrogen. For step 2, remember we take our grams and get into moles. So 80 grams carbon divided by 12 grams per mole equals, let me get my calculator, 80 divided by 12, 6.6 continuing moles carbon. And then do the other one, hydrogen, 20 grams hydrogen divided by 1 gram per mole equals, well, 20 moles of hydrogen. So we know that we've got a 6.6 to 20 ratio. Let's see what step 3 is. Divide each mole number by the smallest mole number and round to the nearest integer. So for carbon, it was 6.6 divided by 6.6 equals 1. For hydrogen, it's 20 divided by 6.6. So let's do 20 divided by 6.6. 3.03. So we'll just round that to 3. So we know that our basic ratio for this compound is C1H3. So C1H3. That's the empirical formula for the compound. Okay, so that's what we did in the last video. Great, good, grand. Now we have to use that and go to the next step. So we found the empirical formula, which is the first thing that was asked. What's the empirical formula? Check. Now we got to go, what is the molecular formula? Which means that we're going to have to use this 75 grams and the empirical formula that we just figured out in order to do it. It's like this. You take the empirical mass, which was for the 1 mole of CH3. This is like the gram formula mass. That would be 12 plus 3, that's 15 grams. Carbon's 12, hydrogen's 3, 3 plus 12 is 15. The molecular mass was the molecular mass given to us in the problem. It was 75 grams. So we got to think, molecular mass is how many times larger than the empirical mass? Well, 15, 30, 45, 60, 70. It's 5 times larger than the empirical mass. So the molecular formula must be 5 times larger than the empirical formula. So you multiply all the subscripts in our empirical formula by that factor, by 5. So our molecular formula, our empirical formula was CH3. Multiply all the subscripts by 5, so C5H15. That would be the molecular formula. So that was like a 4-part, 5-part, 6-part process. Very challenging, but practice makes permanent. So use this guide as we go through some of the other ones. So what's the molecular formula of a compound that has an empirical formula of NO2 and a molecular mass of 92 grams? So the empirical formula has been given to us. Molecular mass has been given to us. So we don't need to find the empirical formula part. So we start in this one with comparing the formula mass of NO2 to the molecular mass of 92. So, you're going to compare 92, NO2, 14, and 32. So NO2's gram formula mass is 14 plus 32 is 46. Yeah, 46 grams. You're going to compare that to 92 grams. If you compare that, you see that 92 grams is twice of 46. And so the second step here is we take our empirical formula and we multiply all the subscripts by 2. That's equals a 1 to 2 ratio. So we multiply all subscripts by 2. So in the original N102, we're going to multiply everything by 2, N2O4. Okay. So that was a pretty straightforward one because it started towards the end of the process. A compound's 50% sulfur and 50% oxygen by mass. We're going to have to start at the very beginning like we did in the first one. So first step, convert your percents to grams. So percent to grams, right? So we're going to have 50 grams sulfur, 50 grams oxygen. Second step, convert grams to moles of each. Okay, that is the second step. We have to find the empirical formula first. Third step, you divide by smallest moles. That gets us to the empirical formula. Then you have to find the next step. Then you're gonna have to find the formula weight of the empirical formula. Then you have to compare that formula weight to 128. Compare formula weight to 128. That'll tell you the ratio that you have to multiply all your empirical formula subscripts by. So then you multiply the subscripts. My gosh, this is a long process, 6 steps. That's like the most that we've ever done. Thankfully, these types of calculations are rare in their entirety. However, I'm thinking I probably should have a quiz on this stuff because I love it. I love the math. The in-depth thinking is what we really want to get at. Question number 3 here. Wow, we're starting with percents and we have to get the possible molecular formulas for this compound. So instead of giving you the grams for the molecule, we have to list some possible ones. We have to maybe figure out the empirical formula and multiply it up by 2, by 3, by 4. So this is a large 4-step problem. So yeah, we're going to have 4 steps here. I want to see you try that. I want to see some scratch work for credit there. Maybe you don't get the right answer, but that's why we have practice problems. Number 4 here. This is a classic by-the-book example of the guided practice that I just walked you through. So go ahead and do this one step by step. Okay, and of course you're going to need calculator, periodic table in order to do this stuff. Let's check it out here. So calculate the molecular formula based on a percent composition. Working backwards, figure out the molecular formula. It's challenging, multiple step problems, but they're going to be good for you if you can work through it. Practice packet, there's 1 page of practice here. We'll be probably re-guiding through in class on this, but still I would love to see a major effort on it in the homework. And we created a small online castle learning assignment for this regarding probably more on the vocabulary and multiple choice type questions that you may see on our exams. So thanks for watching. That's it for the unit. So all we got to do is our POGLs, our practice pack. We got to make sure that we do our castle learning. We got a couple labs to do in this unit. And so I hope that you're going to use these videos effectively and watch them over and over again. Thanks for watching. Bye.